Okay, in this video, I want to just calculate some simple limits, and then in a later video I'll show the definition of this stuff. So anyway, let's say we have a function like 3x plus 2. F of x is 3x plus 2, and we want to calculate a limit as x approaches 2, 3x plus 2. Let's say we want to do that limit. So polynomials are pretty easy. You just gotta plug the number in. So in other words, if when you're calculating the limit, if you can just plug in the number in question in, and you don't get something like division by 0 or square roots of negative numbers or something like that, then that's what you do. You just plug this stuff in. So this, we're just going to plug the 2 in. And when we do that, we get, this is 6 plus 2. And that becomes 8. Okay, so that's pretty straightforward. So let's say we have this polynomial, and we want to do the limit as x approaches 1 of this thing. So we want to calculate that limit. Well, we can just plug this in. Nothing crazy is going to happen like division by 0 or square roots of negative numbers, so we just plug it in. Uh-oh. Pencil's gone. Three times 1 squared plus 2 times 1 plus 1. So I'm just plugging this 1 in there to get this. And then this turns into 3 plus 2 plus 1, and that's going to be 6. So polynomials are pretty straightforward when you're calculating the limits. It's no big deal. So now let's look at some rational functions. How about let's say we have that, and we want to do the limit so we want to calculate that limit. Now if we can just plug this in and not get division by 0, that's what we do. So we're going to just plug it in, and we get 1 squared minus 16 over 1 minus 2, right? And that's going to be negative 15 over negative 1, and that'll just be 15. So this limit is 15. Okay. Let's suppose we have this function. Say we have that. And we want to calculate the limit as x approaches 4. Say we want to do that limit. So we see if we plug 4 directly in here, we get division by 0, right? 4 minus 4 is 0. Plug it into the top, 4 squared is 16, so 16 minus 16, we get 0 over 0. That's an undetermined form. So what we can do in this situation is try to factor this. So let's see what happens when we do that. So the numerator factors, it's a difference of 2 squares, so it's x plus 4, x minus 4. So what happens in this situation? Well, here we see this problem can divide out. If we were going to graph this, we'd say there's a hole in the graph at x equal 4. So what we do is we'll divide that out and have this equivalent problem. So this limit is going to be equivalent to this limit. And we now can plug in the 4 and we don't have any real big problems. And that limit's 8. So this limit is 8. So if we can factor things, divide away the term that's causing the problem, we can get an equivalent limit. Calculate the equivalent limit, and that's what that one will be. Okay, right now I want to return to a problem we did a little bit earlier, namely this one. So I want to do a slightly different limit here. I'm going to do the limit as x approach 2. So with this problem, if I plug in 2, see I get division by 0 right away. The numerator isn't 0 because 4 minus 16 isn't 0, so I don't get 0 divided by 0, but I still have division by 0, which is a problem. So what we did before was factored the numerator. So I want to do that again here. Like this. And the problem that's causing division by 0 isn't dividing out like it did last time. So we've got a problem here. And if I look at the graph of this function, it looks something like this. It's got an asymptote here where we're trying to do the limit. And if we remember the what we had done in the other video, we say, okay, we're trying to do the limit as x approaches 2. So we get on this function and we're surfing towards x equal 2. We're going to positive infinity, aren't we? Because we're approaching this asymptote. If we get on the right-hand side of the function and we're surfing towards x equal 2, we're going to negative infinity. So the left-handed limit and the right-handed limit are different. This limit's not going to exist. And so the reason why we're having the trouble here is we can't divide out our division by 0. And in cases like that, you've got an asymptote you're going towards, and if you're not going to the same place from the left-hand side and the right-hand side, the limit's not going to exist. And in this case, this limit does not exist. So I wanted to show this one again, what happens when we can't divide out our problem. Sometimes from the right hand side and the left hand side you'll be both going to positive infinity, right? If that's happening, then the limit is positive infinity. If from the right hand side and the left hand side you're both going to negative infinity, then the limit will be negative infinity. But in this case we're going to different places from the left and the right, so it doesn't exist. Just wanted to show you what would happen if we can't divide out the problem. See you in the next video.